Right. So last week we had our first physics class. That you joined from. Why you don't come inside here? Got aircon. Shy Huh? They like the hot weather, just want to sweat. You sat on the grass under the sun. Okay then, never mind. I guess comfort is relative, meaning I want eyes on my students. Yeah, I see you here. Okay. All right, so last week, previously, in the previous class, we looked at the different types of forces. Yes. And today we're gonna just do more practice or just talk a little bit about the force types. And then I ask you to try out some questions so we can discuss them together. But today we're gonna focus first on the idea of friction. 1.3, friction. Friction in Mandarin, for those of you who do Mandarin, 对摩擦力. I don't know how to write. Fun fact about Miss Lee. When she had to study science in Mandarin in primary school, I thought I sucked at science because I don't understand. And then so then I went to secondary school. And then it was in Malay because I'm old lah. They taught me in Malay. That was like, it makes sense now. I mean, my Malay is better than my Mandarin, sad to say, because Malay language easier to understand. The Mandarin. During my time, I started Form 1 in 1990. No. Wait. I need to do some maths first because too long ago already. What age do you start Form 1? 13, right? 1998. My Form 1, you born already, not? Not yet, I'm so old. Is it in what? Yes, BC, of course. I am not ancient. I'm not a dinosaur, but you know. So, no. It's, okay. Yeah. Maybe, who knows? Maybe I'm an immortal vampire. I have vampire with a lot of sunscreen. Who knows? Yep. So if you find English a bit difficult, it's easier to always think about the sciences in your native language. Mandarin? Okay, never mind now. Just we'll work with it. Okay, so it says here, slide your finger along the desk wall. No. I am Gen Z, I don't follow instructions. Okay, so does the surface feel smooth or rough? And even really smooth surface? Yeah, I will. If I write the sentence, I'll be like, slide your fingers along your cheek. Is the surface smooth or rough? If it's rough, you need moisturizer. Okay. So what you are feeling when you rub your hand is that the table is pulling your hand in the opposite direction. And that is friction, right? You slide your hand down, you feel that the table is pushing back in the opposite direction. So a surface such as a metal sliding in the playground looks and feels really smooth. Now imagine that you zoom in on it. You actually will see that it is quite rough. So if let's say I take a microscope and I zoom in, I will see that the surface is actually bumpy one. Okay. So thanks. Because when the book is resting on the table, you can push on it, but it may not move because you don't have the gains yet. Friction grips an object, right? And you increase the force by pushing the book harder and the book will start to move, right? And if let's say you remove the force, the book will slow down and stop. So if you've ever pushed anything, isn't this like 4-month-old baby activity? Your parents buy you an IKEA trolley or go Pasar Malam buy you a toy, and then you push the toy. You push toy, you lie down on the floor and then got a lot of toys around you, then you push the toy. Yeah, toy slow down and stop. Yeah, that was 4-month-old life. Then after that, you learn to crawl in 6 months, and then better already. Yeah. So there are frictions gripping the object, and the friction actually slow down stuff. I think we've seen this last week during the class demo, the simulation that I showed you. Okay. So if they ask you to state two things that friction does, just summarizing the point just now, it slows down moving objects. And it also grips object, preventing it from sliding. There's a reason why you are not sliding down your chair, because of the friction between your butt and the chair. So sometimes you go to dinner and then you wear some fancy pants, a very smooth one. And the chair also some fancy chair, very smooth one. And then you feel like you cannot sit properly, you keep sliding everywhere. Ah, oh, you know what? You touch before. I didn't, I don't know, I never touched before. You got to do experiment, very nice. Okay, so most of the time, if you do parkour, you all look at this guy. If you do parkour, you need the friction between your feet or your hand and the surface. Okay, and friction also helps you walk. Have you ever, you know, when you wear a slipper that is like, no friction already, yeah, and then after that it raining, and then you walk on the cement floor, living life dangerously, yeah, and then your foot just slide. Very good, very good. Yeah, that one is a good life. So friction is useful because the friction between your foot and the road produces the force that moves you forward, right? And also at the same time, we brake, and brake also uses friction. But sometimes friction is not good. So a way to reduce friction is by using oil or grease. Let's say you open the door and then you hear the hinge go, like some haunted show like that. Then you go and tell Mr. Or you bring oil put inside the hinge. Okay. So the second thing about friction is that there's this thing called air resistance, or basically friction caused by air. Okay. So if let's say you are swimming through water, or if you are, swimming or paddling through water, you will experience water resistance. Okay. So if you are moving in air, you will experience air resistance. If you ride a bicycle and you open your umbrella, you will experience a resistance. This resistance we normally call drag force because it is dragging you behind. So it's the sensation of like you want to run forward, but the wind is going you back. It's a sensation, it's dragging sensation. No, it will continue to move forever. But we do not exist in a world without friction. Yes, you keep going. No. Very, very little friction because space is not totally empty. Occasionally, you have a few molecules here and there, and then it will slow you down. But overall, you will travel very far, forever. Until you travel close enough to a planet or a sun, and the sun attract you in. Yeah. So currently, you know why the Earth goes around the sun, right? Because the sun is attracting the Earth. You know why you never fall out to outer space, right? Because the Earth is attracting you. Nah, nah, nah. The air only contribute a little bit. It's not the main issue. So to understand drag force, you need to think about particles in air and water. So here you have a solid, this red color thing. And then this is you, okay? Physics people, we're very lazy to draw properly one. So if let's say we have a solid moving through the air particle, it will collide with all of the air particles. And the collision causes it to slow down. But if in water, you got more particle. So this is why drag force in water is more than drag force in air. Yeah. So when do we use drag force? We use it especially when there is a parachute. You open the parachute because you want the air resistance to slow down. You don't want to die when you jump off a airplane with a parachute. Okay. And sometimes we want to reduce drag. So have you seen the Olympic cyclist costume? How does it look like? The Olympic. Let's Google. So you see their outfit, very skin tight one. Not because they want to show off their muscles, although there is a nice side effect. Because what happens when you wear clothing like my one, very loose one, a lot of fabric, then the wind blow against my shirt, it will create air resistance. My shirt will act like a parachute, all right? So, and then you look at their helmet, their helmet very cute one. Okay, you see this? Why the helmet like that one? So at the back there, you see this one, sharp here, one here. Yes, it streamlines, it's more aerodynamic, it reduces drag. And a lot of cars, I mean the sports car lah, not your normal Myvi lah, unfortunately, because Myvi, you know. But you have this teardrop shape looking helmet, which looks kind of cool, also kind of weird. What if you fall on your back? Does the helmet help? I have so many questions. Never mind. Okay. So this is, as you mentioned just now, streamlined. The shapes are streamlined, going to reduce your total air resistance. Okay. Now let's look at your exercise 1.3. Number one, we're going to circle the correct word or phrase in the bold pairs below. So since friction is a type of force, okay, it is measured always in newtons. Okay, it's a type of force. So don't confuse force with mass. They are not the same thing. It acts between two surfaces. You need to touch or not for friction. Cannot just see, oh, my friend has a very smooth face. You need to touch first, right? Yes, very good. It's a contact force. You can reduce friction between two surfaces by using between two surfaces. Two surfaces is lubrication. Streamlining is for drag force or air resistance. Drag/air resistance. Streamline. You draw the person's face and then his weird shaped helmet. Okay. The direction that the force is always the same as or opposite to opposite lah. If not opposite, then it's not called friction now, ma. Must oppose us. Okay. So in some situation, it is helpful to have large frictional force. For example, if I want to brake a car, okay, imagine if you brake a car and then there's no friction, then your car cannot slow down. So which sometimes we don't want friction. So these are 4 examples. What do you think? Do you think whether we want friction or not want friction? Number 1, friction between your shoes and the ground when you walk should be in between. I think for now, I would prefer not falling down. So we need a large friction here. Sorry, what for a shoe with less friction? Got ice skating. Is ice skating a shoe? Turn on my face. Turn on my face. Okay, is ice skating a shoe? Because I'm using this mic. At least I hope I'm using that mic. Because the Zoom box is green lah. So I trust technology. I wouldn't know. Because sometimes I think down, then no one replies me. Okay. So when you brake, The friction between your brake blocks and your bicycle wheel should also be large. Friction between the parts in your car engine, the gear, so on. If not your engine overheat, then boom. Friction between the tire and the road should be So whenever the tire is smooth, the mechanic will ask you to change, right? Yeah lah. Yay. Next, match the beginning of each sentence to the correct end of the sentence. Friction. Okay. It's difficult to walk on an icy pavement before. Nice. Matches. You know what is matches? So friction actually causes heat, right? Generates heat. So it generates heat. So you know the triangle for fire? 1 minute, 1 minute. So the heat is from the friction. The fuel is the chemical or the element that they put on the head of the match. And hopefully you are lighting a match with oxygen. Inhale through your mask, your oxygen everywhere. Should be right. If not, we are like, never mind. Okay, car brakes rely on friction to work. This is very dumb question. So you're gonna look at this one. But this is an interesting setup because the student is going to investigate friction, and he managed to go to go to a hardware store, Mr. DIY, and find some surface of wood and paper and carpet and sandpaper. And then he puts a block of wood on top. Each time he finds that the height he needs, each time he finds the height that he needs to lift the ramp for the block to start moving. So what he did was he basically replaced this one with wood, and then he raised the angle, and then until this thing starts to slide down. And then he measure how high he need to raise, and then he replaced wood with paper and carpet and sandpaper. Okay, put the surfaces in order of most friction, least friction to most friction. Okay, so which surface is smoothest? Carpet is not as so if I don't need to, if let's say this is very smooth, right? I leave a bit, then everything slide already, right? Wow, this one my laptop and my iPad, you good. But also it depends. Maybe my iPad will slide first because this is like it's not very strong friction. But yeah, but this one has that, that rubber thing. So this one will probably slide. But no, this will slide first. Okay. So the one that has least friction will have the lowest height. So least friction here, lowest height, and then most friction is larger height. Okay. So I arrange in order lah. It's gonna be wood, paper, sandpaper, then only carpet. Don't know what carpet this is. Maybe it's the one, the fur very tall one. You know, the fur very tall. And then the thing slide a bit and then stop there, and then slide a bit and then stop there. But sandpaper, once it move, it will just move all the way down. Have you heard of anyone sliding on the carpet before? Not the carpet slide, you. Aiyo. I mean, okay. So blocks of wood, one on top of each other. Hmm. So he go put another wood here. Interesting. What will happen to the height? Increase for one type of surface or for all surface? Okay. So so the height needed to lift ramp for all surfaces. Okay, wait, I'm teaching younger kids. Cannot write like doctor. For all surfaces. Increases or is larger or is greater. Explain your answer. More weight. Hmm. You just say that the contact force between the blocks and the surfaces increase with the weight of the block. I different handwriting. Once you press down more, if you sandpaper, you press down more, right? So if let's say you look at when you look at one block, this is the contact force. But if you have two blocks, double the contact force 2m. So more frictional is like you're pressing down more. And this is called lag. You notice when I write and I speak, it's not the words that come out because lag. This time I will speak slower than I write. All right, so that's friction. The next force we're going to look at is okay. You all have weight, right? Oh, wait. Yeah. You don't think you have weight? Then you're a physics anomaly. How are you still on your chair? Physics anomaly. You are strange. No, strange. Like science cannot explain what is going on with you. We is confusion. Need to put you in the lab to study. We is confusion. What drugs are you on that you feel that you are floating all the time? Yeah, change. Okay, next. So the next time we're gonna look at is those non-contact force. So if you let go of your pen and it move outward, you'll be very surprised. Really? Yeah. Yes. So we are so familiar with the force of gravity, we don't even think about it. So when you were 3 months old and you take a toy and you let go and the toy fall down, you're already doing experiment for gravity. Have you seen babies or not? No. If you stay with one or happen to know one, whenever you go for dinner, the person makes it a personal habit, take the chopstick, cup, spoon, fork, everything. Yes. Oh, gravity. Okay. So gravitational force acts on all of us. Okay, and it's a non-contact force. When you let go of the pen is not touching the ground, but it still has a downward force. If I want friction, it needs to touch. So other types of non-contact force is magnetic force and electrostatic force. summarized this for you already. So speaking of baby, you can, okay, everybody's hair can do this except maybe yours. Yeah. Because your hair is curly and thick. Straight away. Straight away. Because curly hair is just cannot lah. So normally what I'll tell students is you have a ruler, you can try, you take a plastic ruler if you have, and then use a piece of cloth and then see can stick your friend's hair. So what we are going for is all this baby hair. So like she has a lot of baby hair, all these small, small, tiny hair. Boys, you will probably need to use the few strands on top. His hair could be too short, too short. Yeah, so maybe both of you cannot. Too short. Okay. So his hair can. Please be nice to your friend. Yeah. So you can see this baby's hair. What we did here was we rub on the balloon. So paper a bit difficult because paper still can, but it would be great if you have like plastic, like your ruler. Nah, the ruler that you're holding. Okay. So this is all forces. Okay. So in physics, call this force field. Wow, like science fiction. Oh. Field is padang, teacher, padang. Padang, yes. Yes, it's called padang basah. Okay, so in this padang, or this field, is a special region where something experiences a force. So I'll give you an example. Today you go to school, at your school field, got Milo truck. Best day. So what happens? What happens to the students and the Milo truck? All the students be like, yeah, Milo, hey, you go and drink the Milo. Hey, the Milo very best. So the Milo truck creates a region where students experience an attractive force. You are attracted to the Milo truck. And maybe you're allergic to Milo, you just walk in the opposite direction you don't want. Who knows? Okay. So there are a few things about the field. So magnetic field is the field around a magnet where magnetic material will experience a force. That is your magnetic field. Gravitational field or weight is when mass experience a force. So all of these have something in common. The further away you are from the Milo truck, the less likely you will go to the Milo truck, correct? If you happen to walk past, is it a Milo, 顺便 just like, just go. Yeah, but some people lazy one, they lazy to just say no something. For Milo, everything. Okay, good to know. Good to know. But generally speaking, when you get further away, the field is weaker. Makes sense, right? Okay. So these are non-contact forces. All right, I think that's it for this one. So now we're going to look at weight specifically for now. So we can use this thing called the Newton meter. We discussed this last week already. And this device here. The one, the spring one. Hey, now durian season. Who don't like durian one? Why you don't like? Smells bad. Durian smells fantastic. I don't know what you're talking about. I don't think okay, it's okay. So this one we used to weigh stuff, including durians. Okay. So what you are measuring is the weight of an object. So the weight here is your attraction force. So the earth pulls the apple downwards, okay? And measuring the weight of apple means measuring the force of earth on it. So if I design a giant Newton balance and I hook you in the back of your shirt, Newton balance, then I can measure your weight. The shirt will be ripped off. Okay, so what is the difference between weight and mass? So weight is force. So I'm going to build a table because whenever in science, we look at difference means we want to compare, right? So, sorry. So there is weight and there is mass. Which one is the force? So this is force. And if it's force, what is the unit? Newton. Okay, and what is the direction? So-called downwards, right? Or I like to be fancy a bit, towards the Earth's center. Fancy where is down? Down is relative, right? Earth center, but the Earth is attracted to the Sun center. Okay, is mass a type of force? What is mass? The amount of stuff, amount of particle inside. This mass is amount of particle. Fraction thing. Nice. Good call. This is a vector. Have you learned what are vectors and what are scalars? So vectors are things that the direction sort of makes sense, where direction has meaning. So force is a vector because whether I pull or push the water bottle towards you, the effect is different. But the mass of my water bottle, if it's 800 grams here, it's still going to be 800 grams here, and it's going to be 800 grams here. It doesn't really, the direction does not make sense. The water bottle mass is a constant. Okay, is there a way to calculate weight? You can. Okay, so we give Earth's gravity a very nice number, 10. 10. It's 9.81 or 9.80 something. What? So if I go back to this one, and I want to join W, G, W equal to mg. Okay. So what this weight is equal to mg. So mass of the object that you are measuring, and G here is gravitational field strength. Yes, or unless you're very far away. And to make life easier, we won't use 9.81 yet. We will use it in A levels when you are in college. So currently, we're just going to use 10. So we round to the nearest integer. 9.8 is 10, right? Yeah. So it means that for every kg you are, you have 10. For every kg you are, the Earth is like, I will pull you down by 10 Newton. Let's say she's 40 kg. So the Earth is like, okay. So it's like you do stock exchange like that. You are 40 kg. So the Earth will pull you down by 400 Newton. And the Earth is fair one. The Earth is fair. Let's say you 50 kg, the Earth will pull down by 500 Newton, right? So the Earth is fair. Every kilogram you are, you have extra 10 Newton. Let's go to another planet. Have planet A, where the gravitational field strength is not 10 Newton per kg, it's actually the moon. Which means your muscle that is designed to carry 400 Newton is 6 times more powerful. Wow, you can lompat jauh, lompat tinggi, lompat very far. You're very strong already, very strong. And then after that, we bring you to planet B, where G is 20 Newton per kg, GG. You're going to feel like very heavy. Wow, I cannot even walk. Every step, my leg is so heavy. Do you know what will happen to the human there? If let's say we go to the planet, they become wider, yes, and then become shorter, correct? Then they will look like tiny little garden gnomes. So if you think about the average human height for, let's say for guys, the average height is around 5'8". 5'8" in cm is around 178, 118. 178, 180 like that lah. Okay, let me Google. Of me. 1.7 meter. Female is 1.6 meter average height lah. But this one include all the Asians lah, because Asian tiny, what to do? Asian tiny. Okay, anyway, so what will happen is the average height of the human will drop maybe to 1.2 or 1.3 meter because your body need a lot of effort to grow upward because gravity too strong now. So you become like that and like that. It's not very attractive. Attractive for us because we equate height to attractiveness lah. We all want to be taller. It's nice to be taller. Taller people, 比较好看. But maybe in this planet, you let it pass by some time. Maybe the shorter and the wider you are, the more attractive you'll be on this planet. But we flip the beauty standard now. Who say my store is pretty? Who say the newspaper tell us the? If you know why or not, if you think that the only way you can look nice is to be taller, they get to sell you shoes. Yeah lah. Yeah lah. No, you should look at the shoes that most ladies wear. Okay, anyway, back to the issue at hand. So because of this, we can actually find gravity. But now let's think about what happens to your weight in space. So imagine you are playing Among Us and someone float you Among Us, no more already, you cannot blast off. Okay, and as you move away from the Earth, the gravitational field is weaker. Yes, but the amount of the part of you will not change, so your mass stays the same. But the gravitational field gets weaker. Your weight is less. So you will reach a point where you're floating in the spaceship. Yes. Yep. Yep. Okay. Let's look at 1.4. In fact, we have many examples of weightlessness before. So I guess maybe I will show you the weightless plane. Then you're weightless already. Yep. So you can actually pay to go on this 0G aircraft one. Okay, let's watch a video. And gonna copyright strike when I upload. So right now,
I'm experiencing 1.8 Gs
right now. The lag. Amazing. Okay, so this plane is at 7-degree angle. I want to explain what it means on this number first. Flat is 0 嘛，上一点点 is 7 哦。And 1.7 G is 1.7 times 10. Currently, we are all at 1 G. Yes, because of how the plane is accelerating. So we will see what happens.
Which means I weigh about 1.8 times what I normally would. I've been instructed to keep my head front and centre to avoid nausea. But all this is about to change because this is the European Space Agency.
Yeah, your neck can break one.
Those are students doing research. This is Neil who's here for my safety. And
disappear and they
fall. Whoa! Whoa! And here's the confusing thing. We are still going up right now. That camera is stabilized to the actual horizon. And it's not until 10 seconds into our 20-second parabola, into our maneuver, that we clip the apex and start heading back down towards the ground. And here we go, 1.8 Gs. Oh.
Wow, so high.
And start heading back down towards the ground. And here we go, 1.8 Gs. Oh.
In this special aircraft, we divide the three axes, pitch, roll, and thrust. And each pilot fly one axis. So in every other aircraft, one pilot flies the three axes and the other one manage the system, talk to the radio, and so on. To fly parabolas, we need to fly only one axis by one pilot. We try to avoid any turbulence. Every turbulence is a nightmare for us.
The two control sticks, just like any plane, are completely locked together, so they always move at the same time. So one of the pilots is using effectively elastic bands on either side of his stick so that he doesn't affect the axis of the other pilot. One of them does the pitch, the other one does the roll whilst trying. This doesn't seem like a very good idea, guys. And one of the pilots that isn't too busy on the other two axes is turning off the alarms that we don't need to worry about and keeping track of the ones that we might need to worry about.
So those pilots are keeping us on the exact path that an object would take if you hurled it into the sky at hundreds of kilometers an hour and there was no air. They're giving us this little protected bubble of 0 G to fly around it. There is no terminal velocity here, only the design limitations of the plane. And we're going to hit something else, because when the Earth approaches pretty quickly. Thank you, Neil. If you're a master's or PhD student from an ESA member state and you want to be one of the people back there,
my connection.
I give you hotspot.
You give me hotspot. I think you need to give the laptop hotspot. But never mind lah, never mind lah. Next week lah, next week. Okay, we're back. Hopefully. Okay, so at the end of today's class, I will create another channel called Past Recording.
Yes.
And then I will put the link there for the 0 G videos.
Press that.
No.
Oh.
Too slow now.
I see.
Slow already. Okay, so we're gonna. That's not Star Wars. We're gonna continue now. Hoping the internet will hold. Hoping. Cross my fingers. Okay. In this diagram, you are in UK and your friend is in China. I try to read China. Okay. Draw arrows to show the force of gravity acting on each person. Towards, is it all downward like that? You say downward, 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 downward. Yeah, I know, I'm just GG. Okay, so mark the center. Must be pointing to the center of the earth, like that. If not, then this hand is waving bye. Okay. A student is investigating the link between weight and mass. He takes some measurement and puts them on the table. Fill in the unit of weight on the table. In the table, not this table, but the table of table like jadwal. Jadwal is table, major also table. How? Okay, so look, you wouldn't hear Cambridge call this thing a table. I teach there. It doesn't look like this, fake news. I cannot change the, this is not my laptop, so I'm not allowed to change the screen saving. Yeah, then for Christmas, you buy me a laptop, lor. You start saving up, start fundraising. Buy Miss Lee a laptop. Contribute to the Miss Lee laptop fund. Weird flex, but okay. Weird flex, but okay. All right. Oh, okay, anyway, which way is correct? The weight of 200 gram. What is the correct weight? 2.0 Newton. Number 3. The top drawing on the right shows part of a ride at a theme park. The back is... Which arrow shows the direction of the weight of the people sitting in the carriage? Not A. B. Weight of the... Weight is this one, right? Then this one is on the this one, second diagram. Still D, not B. No, not the leg there. They try to cheat your feelings. So if you think of roller coasters, okay, I can't share video with you, so I throw link in Discord, okay? So if this is your roller coaster and this is your feet, weight is still downwards. If this is roller coaster and this is your feet, bye-bye lor. No, actually, if you don't wear a seatbelt, you'll be okay. Tomorrow tomorrow. Next class, I bring a demonstration to show you. Not really a roller coaster. It's like your Hot Wheel track. So when you correct the centrifugal force. I bring something to demo to you. But it won't fall one. It's a bit like, you know, the washing machine, you put in clothing from the front one, and the clothing turn, the clothing don't fall down. So if this roller coaster is fast, nothing will fuel strength